Hi, Pre-Calc. Sorry I can't be with you today to do this lesson, but this will just have to be the next best thing. Woo! All right, so we were looking at limits. We had a couple more examples in this next one. We're looking at the limit as x approaches 3 of x squared minus 9 all over x cubed minus 27. And of course, our first step is always to plug in the value, so we have 3 squared minus 9 over 3 cubed minus 27, but as you can see, we get 0 over 0. Thus, that means we need to do more work. Well, what work do you think we need to do? Probably factor. And hopefully you're looking at the top and you're thinking, well, I can see how that factors, because it's the difference of squares. So we have x plus 3 times x minus 3. I'm looking at the denominator and I'm not totally sure, but I do notice it's x cubed minus 27, which is really 3 cubed. And guess what? That is something called the difference of cubes. Now, I wouldn't expect you to know this right offhand, so we're going to look it up because that's okay. We have difference of cubes. So we have a cubed minus b cubed is equal to a minus b. So in this case, x minus 3 times the quantity a squared plus ab plus b squared. So in that case, it would be x squared plus 3x plus 9. I like this because look, my x minus 3's cancel. And now I have the limit as x approaches 3 of x plus 3 over x squared plus 3x plus 9. If you want to pause the video and plug it in and evaluate and simplify, but when I do that, I get 2/9. The other example in this section is the limit as x approaches 0 of absolute value of x over x. And we will move this one, oh, just kidding, they're the same. So this is going to be a problem where it makes more sense to consider what does the graph look like. And if you remember, for absolute value functions, we're really given two pieces. So this is really the positive version, or x over x, if x is greater than 0, or the opposite of what's inside, negative x over x, if what's inside is less than 0. X over x is really 1. Negative x over x is really negative 1. And so what does this graph look like? It's the line y equals 1 when x is positive. Oops, that was supposed to be 1. And it's the line y equals negative 1 when x is negative. And so if we want to find the limit as x approaches 0 here, what do we see? Well, as I come at 0 from the left, as I come at 0 from the right, I approach two different values. What would we say then? This limit does not exist. And this is going to be really true for a lot of functions that look like this, where this guy is really just going to be a horizontal shift of the function above. I mean, we could do the same thing. The absolute value of x minus 4 all over x minus 4 is really keep what's in there, x minus 4 over x minus 4, if whatever's in there, x minus 4, is positive, or it's the opposite of that thing, over x minus 4, if what's inside is negative. All right, this one's still 1, this one's still negative 1, but the thing is, this becomes x is greater than 4 or x is less than 4. So this function looks very similar. It's got these lines here and here, but it just moves over to 4. And again, as I approach 4 from the left and from the right, I'm hitting two different values, so I would say this limit does not exist. Those were the extra pieces for limits day 1. The worksheet, evaluating limits graphically and algebraically, is due tonight by midnight. So hopefully you'll have some time in class today to work on some problems, ask your peers, If there's one or two problems that you're still stuck on, we can go over them next week.